Okay, here are a principle of HPLC. HPLC is a high-performance liquid chromatography, works by separating a sample based on the distribution of its component between a mobile phase solvent and a stationary phase column packing material. As the sample moves through the column, its molecules interact differently with the stationary phase, causing them to be retarded to varying extents, which result in the component being eluted at different times. A detector, such as a UV detector, identifies the analytes as they exit the column, and the signals are recorded in a chromatogram by a data management system. An HPLC system typically include a solvent reservoir, a pump, an ejection valve, a column, a detector, and a data processing unit. Okay, we have 7 components in HPLC. The first one is solvent reservoir. It holds the chemical solution, mobile phase, that move throughout the high-performance liquid chromatography system. Next is pump. Pump pulls the mobile phase from the reservoir and push it out to the rest of the system. Next, injection valve. Introduce the sample into the mobile phase. After that, column. A tube usually filled with small beads coated with a chemical substance designed to act a chemical filter. Stationary phase that interacts with the sample and enhance separation. After that is a detector. Views the sample components that are separate in the column as they are carried along by the mobile phase. Next is recorder. Translate the signal generated by the detector into a graph called a chromatogram. And lastly is waste reservoir. Safely collects all the mobile phase and sample components after they pass through the HPLC system.
So, what is application that HPLC use to analysis of glucosinolates in oleracea? Firstly, it used to analyze of monosaccharide composition. How? Oleracea sample we inject in HPLC and pass through column to separate based on size and polarity and also other properties. Secondly, to determine levels of vitamin and nutrient. Vitamin can be analyzed using specific methods suited to their chemical properties in HPLC. And last but not least, HPLC is used to detect and quantify pesticide residues in oleracea for safety. HPLC coupled with mass spectrometry for high sensitivity detection of pesticide residues. There are 2 objectives in this experiment, which is firstly to determine constituent in Pucelleka oleracea L from different locations by a sensitive high-performance liquid chromatography, or we call it as HPLC. And secondly, to obtain a good chromatographic peak for each analyte and simple mobile phase.
Hi, my name is Sophia. To analyze glucosinolates in oleracea, I followed a systematic methodology. Number 1. Sample preparation. Fresh oleracea leaves were cleaned and dried at 50 degrees Celsius and ground into a fine powder. 5 grams of the powder were extracted using 50 ml of distilled water in a water bath set at 70 degrees Celsius for 30 minutes. The extracts was then filtered and stored at 4 degrees Celsius until further analysis. Number 2. Preparation of standards. Glucosinolate standards were prepared at concentration ranging from 10 to 100 ppm. These were used to construct a calibration curve for quantification. Number 3. The HPLC setup. The HPLC system was equipped with C18 reverse phase column. The mobile phase consisted of acetonitril and water in 20:80 ratio, adjusted to a pH of 2.5 using phosphoric acid. The flow rate was set at 1 ml per minute and the detection was performed using a UV detector at 229 nanometer, which is specific for glucosinolates. And number 4, chromatography analysis. The OLERACEA extract was then filtered through a 0.45 micromembrane filter and 20 microliters were injected into the HPLC system. The retention times of the sample peaks were compared to those of the standard to identify and quantify glucosinolates. Number 5, data analysis. The peak areas were used to calculate glucosinolates concentration using the calibration curve. Results were expressed as milligrams of the glucosinolates per gram of dry sample. That's it for me. Let's move on to the next section.
Assalamualaikum and hi everybody, I'm SHASHA and I will be presenting about the result and the discussion in this case study. So, after we have obtained the data from the HPLC, the graph will later on obtain from the sample of OLERACEA. After that, we summarize all the data from the graph right here into one table that we will be discussing after this. Now, this table right here summarizes the glucosinolates detected in the OLERACEA, highlighting their retention times RT, names, and chemical characteristics. Each column provides key information about the compounds. The analysis of OLERACEA glucosinolates by using chromatography brought out different peaks that are corresponded to the mentioned compound. The first significant peaks that we can see in the chromatograms with an elution time of approximately 9.26 minutes identified and confirmed qualitatively and quantitatively as progoitrine and aliphatic glucosinolates with a response factor equivalent to 1.09. The next peak that are slightly smaller intensity at around 10.11 minutes is related to the cyanigrines, which also belongs to the same aliphatic groups. The first detected photoxylate is gluconafine that appears at the retention time of 12.68 minutes, while the second one was identified as glucobrasicin and endolyl glucosinolates which exhibit a large peak at 16.20 minutes. Other two peaks at around 17.80 minutes and 19.40 minutes are the third form methyl-C glucobrasicin and the neo-glucobrasicin. Well, that is all from me. Now we are moving to HUSNI. Back to you.
Hi, my name is AMIRA HUSNI Madani. So we are moving on to the next part. HPLC offers several advantages. It is highly sensitive and can detect even small amount of this compound, also providing accurate measurement of individual glucosinolates level. Next, HPLC is a well-established and widely used technique with numerous validated methods available, making it a reliable choice for glucosinolate analysis. However, there are some disadvantages to consider. HPLC instrument and supplies can be expensive, and the process of sample preparation and analysis is often consuming. Furthermore, operating and maintaining the equipment as well as interpreting the data requires trained personnel, which can be limitation in certain settings. Now let's look at the application of HPLC. HPLC is widely used to investigate the potential health benefits of glucosinolates. For instance, their role in cancer prevention, antioxidant activity, and anti-inflammatory effects can be better understood by accurately analyzing their concentration. Next, safety is another critical application. Some glucosinolates breakdown product can be toxic at high concentration. Using HPLC, we can monitor this compound and ensure that food products are safe for consumption. And finally, HPLC helps in agriculture studies. Researchers use it to study the effect of different growing conditions on glucosinolates production. This helps in optimizing conditions of improved crop quality and maximize the beneficial properties of this compound. Okay, so that as you can see, HPLC is a versatile tool that ensure safety and quality in food and agriculture.